Everyone, welcome to our next video, and in this lecture we'll be discussing about the remaining reactions of acids and bases and also about the pH of acids and bases. So let's get started. Next reaction that we are going to discuss will be about the reaction of metallic oxides with acids. So I have to take one metal oxide, react it with an acid. What we get is a salt and water. So let us look at one reaction. So let us take one metal oxide. Metal oxides can be anything like sodium oxide, magnesium oxide, aluminum oxide, ferrous oxide, calcium oxide. So let us take one example. Suppose I take magnesium oxide, this is MgO. I react it with an acid. Let us take H2SO4, this is an acid. So if I react metallic oxide, this is a metal, this is an oxygen, metallic oxide with an acid, what I should get is, from here magnesium will react with the sulfur. So it will sulfate, so it will give us magnesium sulfate, MgSO4. Okay, and what we are left with is oxygen and hydrogen, so it will give us H2O. So this is a balanced reaction, we don't have to balance it anymore. So what we have here is a metal and an oxygen, so giving us metal oxide. Here we have one acid, which will be a proton donor, because acids donate protons, so they have H2, so they will have 2 H plus ions donated in the solution. So this will release the proton. This proton, that is hydrogen, will react with oxygen to give us H2O, that is water. And this sulfate, which is having a negative charge, will react with magnesium, which is having positive charge. So let's see how this happens. Here what happens, this MgO will break into Mg2 plus, oxygen will break into O2 minus. Here H2SO4 will be broken down into 2 H plus ions and SO4 will be SO4 2 minus. So what happens here is Mg2 plus and SO4 2 minus will react, and hence we need 1 Mg and 1 SO4 2 minus to give us a neutral compound. This is a salt. And here oxygen, which is 2 minus, 2 negative charges, will react with hydrogen carrying 1 positive charge, so we need 2 hydrogen. So 2 negatives and 2 positives will react together to give another neutral compound. Okay, I hope that's clear. So this is what happens. Here metallic oxide will react with acid to give salt plus water. Now I want you to look into this carefully. If you remember the reaction between acids and bases, we had acid. Okay, let me erase this part. If we look into that reaction, we had acid reacting with base, give us salt and water. It is almost the same case here. Here we have an acid, one metal oxide, giving us salt and water. If we want to relate this equation with this equation, what we see here is all these things are same. Acid, acid, salt, salt, water, water. In place of base, here we have a metal oxide. So looking into the similarity of these reactions, we can easily state that metal oxides have basic properties. Okay, so metal oxides will react or will act like a base. So remember this point, that metal oxides are basic in nature. They are not acidic, they are basic in nature. I hope that's clear. Now let us move on to the next reaction, which will be the reaction of non-metallic oxides with base. We will have a non-metallic oxide. This time we will not consider a metal. We will have a non-metallic oxide which will react with base. Again we will have the same products, that is salt and water. So now let us take one non-metallic oxide, which will be, suppose we take carbon dioxide. Oxygen will act as the oxide and carbon is a non-metal, so carbon dioxide. And here we take one base, which is calcium hydroxide. This is one base. Now let's see what happens. In this reaction, what we will have is, this calcium will be forming one salt, and the salt will be calcium carbonate, CaCO3, and the remaining will be water. So let's see how this happens. This will break down into carbon and this will break down into oxygen. This will break down into calcium ion and this will be into twice OH minus ions. So what we have here is, this is 4 plus. We will have calcium bonding with this carbon and we will have oxygen also with it, and one oxygen from here also will come. Okay, so we have carbon, we have calcium, and we have 1, 2, Here we go. So we have one carbon. Here we will get two oxygen because O2, so two oxygen. Here one carbon, two oxygen, so we will have carbon dioxide, and another oxygen will come from here, making it carbonate. So ultimately what we get from here is CO3 2 minus. Okay, calcium carbonate, and with it calcium will bind, so we get calcium carbonate, and this calcium carbonate we have here. Okay, let me repeat this again. We have carbon dioxide, two oxygen ions and one carbon ion, one calcium and two hydroxide ions, since here we have two. So we will have the calcium here, we will have the carbon here, and we will take two oxygen from here and one oxygen from here. Okay, so we will get the carbonate. Calcium carbonate is the salt, and we have one water molecule because from here we will have two hydrogen and one oxygen left here, because one oxygen we are taking away and one oxygen will be left, so we are left with water. Okay, so that is the reaction. Now again, if you look into this carefully, we have one base, one oxide, salt and water. Thinking about the same reaction earlier, we had one acid, one base, reacts together to give salt and water. Here we see base, base, salt, salt, and water, water. These are all common. So what is not common? Here we have one non-metallic oxide and here we have one acid. That means if we compare these two reactions, we will understand that acids and non-metallic oxides have similar properties. That means non-metallic oxides will act as acids, not as bases. So metallic oxides will be acting as bases and non-metallic oxides will be acting as acids. Okay, these are the two properties, important properties that you need to remember. Metallic oxides acids, non-metallic oxides, I have done it wrong. Metallic oxides bases and non-metallic oxides will act as acids. Okay, now we will move into our next part, which is what happens to acids and bases when they react in water. I have already mentioned about this in my previous lectures. What happens to acid in water and what happens to acid in base. So let us look into it once again. If we have an acid in water, this is the reaction that we want to see. So for example, let us take HCl as the acid and water we have here. Now you see, HCl, as I mentioned earlier, in an aqueous solution, means in water, it will release the proton, it will release the H+. Okay. So here, what actually happens is, this HCl breaks down to H+ and Cl-. Okay, and since H+ is very reactive, this H+ will react with water. As a result, what we get is a positively charged ion, which is H3O+, called the hydronium ion. And the remaining Cl- will come here, plus Cl- one chloride ion. Okay, so this is what happens to acid when it reacts with water. So if you put any acid in a water solution, you will have the acid breaking down into the proton and the one cation and one anion. This anion will stay as an anionic form. This proton will go ahead and react with water. As a result, we will have three hydrogen, one hydrogen here and two hydrogen here, making it three hydrogen and one oxygen. As a result, it was neutral, but one extra positive charge has been added to it, and as a result, the whole thing becomes positive. Okay, this was neutral. Water is a neutral compound. We have one extra positive ion added to this. So since we have one extra positive added, that's why the positive charge. Chloride will remain as chloride ion. Okay, so acid reacts with water to form hydronium ion and a non-metallic ion. Okay, this will be a negative ion of any non-metal that was present in the acid. Now what happens to bases? In case of bases, it is pretty simple. If you have base in water, it will give rise to one cation and one anion. So let's see how that happens. If we have one base and we react it with water, let's see what happens in this case. Let us take NaOH. NaOH will split into Na plus and OH minus. Very simple reaction. NaOH directly splits into Na plus and OH minus, and they will stay in the solution. Okay, since Na plus is not as reactive as hydrogen ion, that is the proton, that's why Na plus will stay in the solution as Na plus, and OH minus, which is the negative anion, it will stay in the water as well. So we will have one positive ion and one negative ion present in the water solution. So if you have acids in water, it will produce one hydronium ion. Hydrogen ion will react with water to give H3O plus, which is a hydronium ion, and one anion, that is a negatively charged ion we will have. If base reacts with water, then we will have the base will split itself into sodium ion and the hydroxide ion, or whatever the base. If it is carbonate, then it will be a carbonate ion, and similarly. Okay, so these are about the reactions of acids and bases in different conditions. Now let us move into a very important topic, that is pH, which I have discussed earlier. So pH is a measurement. Just like we have for temperature, temperature is a measurement of heat. Similarly, pH is a measurement of the amount of acidity or basicity in a solution. So, as I said earlier, the range of pH lies between 1 to 14. The central value is 7. So, if the value of the pH is 7, that means the compound is neutral. If it is more than 7, that means it is basic in nature. If it is less than 7, then it is acidic in nature. Okay. So how do we define acidity or basicity? If you remember what I said earlier, acidity means the amount of hydrogen ions present in the water solution. So if any compound is added to a water solution, it dissociates into hydrogen ions, it gives out hydrogen ions, then it will be called acidic. So acids will always give out hydrogen ions, so more amount of protons in the water solution. As a result, it is more acidic. And here we will have less amount of hydrogen ions, because whatever hydrogen ion will be produced will be taken up. So they will be acceptors of protons. Acids are proton donors and bases are proton acceptors. You remember this from a previous lecture, the first lecture on this chapter, the introduction that I gave. So since they are proton donors, they will be donating more protons in the water solution, and bases will be taking away more amount of protons from the water solution. So now why did I say this? For better understanding, let me mention this part. Amount of hydrogen ion in the solution will give us the definition of acidity or basicity. If more amount of hydrogen ions are there in the solution will be acidic. Less amount of hydrogen ions are there in the solution will be basic. So pH is measured based on hydrogen ions. Okay, so if in a solution we see that the hydrogen ion is huge, its pH will be acidic, and acidic pH means less than 7. If the pH is more, if the pH is more, that means it is basic. That means hydrogen ions will be less. Okay, so a very important thing is pH is inversely proportional to the amount of hydrogen ions present in the solution. So if more hydrogen ion, less pH means acidic. Less hydrogen ions, if hydrogen ion is less, pH will be more, and we will have a basic environment. Okay, so they are inversely proportional. If one increases, the other decreases. I hope that is clear. If hydrogen ion is very much in number in the water solution, then the solution will be acidic and having less pH. If this is more, this is less. If this is less, then this one becomes higher. Okay, so that is about acidity and basicity. Whether a substance is acidic or basic, we determine it with the help of pH. Now, there are many other aspects of pH, like how pH is used in everyday life, how in everyday circumstances we encounter pH. So we will discuss about that in our next video. So today, up to this much is what we have for today. We have discussed about the remaining reactions of acids and bases. Then we have moved into the pH. If pH is clear, then it will be really helpful for you to understand the future videos. So we will be coming up with the remaining part of this chapter. So till then, please wait and try to understand whatever is here, whatever is explained till now. Make these things very strong. If these things are clear, it will be easier for you to understand the next videos. Until then, thanks for watching and cheers.